So, good evening and greetings. Let us start the next part in this chapter. So, we saw rational numbers. What are rational numbers? We compared the rational numbers. We also tried to represent the rational number on number line. We also had learned about decimal representation of rational number. We learned about terminating decimal form and non-terminating recurring decimal form of rational number. Now apart from this, there are other numbers as well on the number lines which are not rational number, and those numbers are known as irrational number. Okay, the numbers that are there on number line but they are not rational number, then those numbers are called as irrational number. And one example is square root of 2. So now square root of 2 is an irrational number, but how will you locate it on your number line? So when you have this number line, okay, so you will require here to use circular and also the basic Pythagoras theorems that you have learned in your earlier classes. So you have 1, you have minus 1. Now this length is 1, and let us say we call this as OA, and you can also draw one more perpendicular to the point A equivalent to 1 centimeter. Okay, so let us draw that equivalent to OA. You draw, say, segment OP, segment AP, which is also 1 centimeter or 1 units, I would say. So this is 1 unit, this is 1 unit. Now we have learned Pythagoras theorem that if in a right angle triangle sum of the square of one side and the other side is equivalent to the square of hypotenuse side, that is OP square. So now we have these values 1 square plus 1 square, which is equivalent to OP square. Now this will be equal to 2, which is equal to OP square. Now I have to find just OP. What I will do is taking square root on the both side. So taking square root on the both side. Now this square root and this square gets cancelled over, and you will just get OP as square root of 2. So now the value of this OP is square root of 2. Now you can represent this in number line. So how you will do it? You have to take your rounder or circular. You have to measure the length of OP using the rounder, and you have to draw an arc from P to your number line. So you will see the arc going or passing through the number line in some point. Let us mark this point as M. So now the distance of OM will be equivalent to square root of 2. The distance of OM will be equivalent to square root of 2. Why? Because this lies on the same circle of OP. So OP is a radius with measuring square root of 2. Similarly, OM will also be the radius, and its length will be also square root of 2. So similarly, you can locate square root of 3, square root of 4 and square root of 5 in square root of 3, square root of 5, square root of 7 in number line using similar principle. And now let us locate square root of 3. You have this as an activity in your practice set. So let us do that. I mean, we know where your square root of 2 now is. Okay, so you know this length is square root of 2 OM. You draw a perpendicular from point M to point N, and let that measure be equivalent to 1. Okay, so now you have square root of 2 and 1. Again use the same Pythagoras theorem. Square root of 2 square plus 1 square is equals to segment ON square. Right, this ON is not known, but soon you will see that ON square is equals to 3, and taking square root on both the side, ON will be equivalent to square root of 3. So now ON is square root of 3. You can easily draw a arc from point N measuring ON onto the number line, getting a point, say Z. So OZ will be equivalent to square root of 3. And similarly you can find square root of 5, square root of 7, and goes on. Likewise you can find the rest of the locate the rest of the rational numbers like square root of 2, square root of 3, square root of 5, square root of 7 on number line. So for square root of 5 you draw a line which is equivalent to square root of 2, because square root of 2 and square root of 5 will be getting you square root of 2, and square root of 3 will getting you 5, square root of 5. So you draw a line equivalent to square root of 2 from Z to any point mentioning say X. So this measure will be square root of 2. This measure is square root of 3. Apply hypotenuse theorem and OX will be equivalent to square root of 5. And again you draw arc and you will get you a point, say L. OL will be equivalent to square root of 5. So this way you can understand or draw these irrational numbers on number line. So there are many numbers, like in previous standards you have learned pi, right? The value of pi as 3.14, but in actual it is not 3.14. It is actually 3.14 and then some other numbers going ahead, but just to approximate it we say pi ka value is 3.14 or 22/7. So in real life, in actual life, pi is also a irrational numbers. Now some numbers like say 2√3, this can be also a irrational number. Why? Because once you divided this number by 2, then you get 3, which is an irrational number. Therefore naturally square root of 2√3 is irrational number. Just 7 plus square root of 3 will also be an irrational number. Negative of square root of 3 will also be an irrational number. So in this chapter, like, we have tried to understand now what irrational numbers are, and collectively we have learned what rational numbers are, what irrational numbers are, how to locate the rational number and irrational number on number line, and we also learned decimal representation of the rational number on so we learned recurring and non-recurring, terminating, non-terminating rational numbers. So thank you for watching video. See you on next video.